To find the antiderivative of this function, we're going to need to use substitution. So I'm going to need to let my inside function, the derivative of the inside function, be the value of the outside function. So if I let log x plus 1 be my u, then my du is the derivative 1 over x plus 1. And I can see that there's my 1 over x plus 1 and times the dx. So I forgot to put the dx on there, so I need to move my dx over here. So there it is. There's my derivative, and it takes care of whatever's left over after I differentiate the inside function. So my new integral becomes 1 over u, and then I can replace the highlighted 1 over x plus 1 dx, I can replace that with a du. And that becomes an integral in terms of u, so this becomes log u, don't forget the plus c, and then I'm going to back substitute. Well, u really isn't u, but u is really log of x plus 1. So there's my log. So there's my antiderivative function, and again, don't forget the plus c. This is a definite integral, so we need to calculate this area, but for this one here, again, we're going to need to use substitution. So if I take a look at this, this is looking like my arcsine antiderivative. Okay, but I have to take a look at that, and I say, well, I have the inside function is going to be inside the x squared. So I'm going to just rewrite this. And I have my 2x over square root 1 minus x squared squared. And if I let my inside function be x squared, then my derivative is going to be 2x, and then I'll move the dx over to this side, and I can see that my derivative then accounts for what's left over. So there's my leftover term. Okay, that's going to represent my arcsine, and the derivative of the inside accounts for that outside function. So I'm going to go ahead and do my substitution. Now when I do my substitution, I have to be careful because I'm going to change it in terms of u, but my bounds are in terms of x, so I need to switch my bounds from negative 0.5, x equals negative 0.5 to x equals 0.5. So because my integral is going to be in terms of u, I need to make sure it's clear that the variable of which my bounds are with. So this becomes 1 over square root 1 minus u squared. And then I can replace the 2x dx with my du. And so now I can evaluate this antiderivative. So undoing this, I get arcsine of u, and I'm going to evaluate this from x equals negative 0.5 to x equals 0.5. Now we could possibly, if we want to keep the u, we can actually just change our bounds into values of u. So I could just plug in negative 0.5 into this expression, and I can then plug in 0.5 into this expression, and I can write my bounds in terms of u. But I'm going to keep it this way. I'm going to switch it back to x's, so I end up with sine. So that really is x squared. The u is defined as x squared, and then I change my bounds back into terms of x. So I don't need to put the x equals anymore. And then I can evaluate this. So I get sine of 0.5 squared, which is 0.25, and minus sine of negative 0.5 squared is 0.25 again, so that the net area works out to be 0. Okay, so the area underneath this curve from negative 0.5 to 0.5 is going to be 0. It's likely because it's an odd function and half of it's below and half of it's above.